Hello students, in this lecture also I am going to discuss about 8051 microcontroller assembly language programming. In the previous lecture I discussed few instructions. So let me tell you, basically any assembly language program, what is it? It is like a set of statements. There are set of statements. So these statements, either they may be instructions or they may be directives. So what are instructions? As you have seen in the previous program, like MOV A, 23H, any instruction like MOV, ADD, these are called instructions. And what is the purpose of instructions? These instructions, they are for CPU. They tell the central processing unit what to do. They tell the microcontroller what to do. These instructions like MOV, ADD, SUB, these instructions tell the microcontroller what work they have to do. Whereas directive are those statements that tell assembler what they are supposed to do. For example, a few example of directives like OR, G, E and D. As you can see in this program, like ORG, E and D, these are the directives, where rest are the instructions. So instructions are for the microcontroller to tell them what is their work, what they need to do, whereas directives is for assembler. These directives tell the assembler what they are supposed to do. For example, the purpose of ORG instruction is to tell the assembler that they have to store the opcode of the next instruction, the upcoming instruction, in the memory location 0000. Again, I am repeating, what is the purpose of ORG? The purpose of ORG is to tell the assembler to store the opcode of upcoming instruction in the memory location 0000. Whereas END, it tells the assembler to end the program. So ORG is for starting the program and END is for ending the program. Like, let us take the example of this program. ORG 0H means the memory location 0000, since it is ORG 0 written here, so the memory location 0000 is going to store the opcode of the upcoming instruction. So what is the upcoming instruction? The next instruction is MOV R5, 25H. So how this instruction is going to get stored? MOV R5, 25H. So this instruction is having opcode 77D. This instruction MOV RD, data is having opcode 7D, whereas 25 is the data that needs to be stored in the memory location, that is the immediate data. So what is the purpose of this instruction? MOV R5, hash 25H means R5 is going to store the value 25. And how this instruction is going to get stored in the memory location? Since previously ORG 0H is written, so in the memory location 0000, 7D is going to get stored, that is the opcode of the instruction, and the next memory location 0001 is going to store the 25. So this instruction is going to occupy 2 bytes, like 0000 and 0001. So these two memory locations are for this instruction, and the next memory location like 0002 will be for the next instruction. So what is the next instruction? It is MOV R7, hash 34H. Again, it is a 2 byte instruction, one for the opcode, that is 7F, and another for the operand, that is 34. So 0002 is going to store the opcode 7F, and 0003 is going to store the operand 34. So 2 bytes of the memory location will be occupied by this instruction. And what is the purpose of this instruction? 34H is going to get stored in the register R7. Similarly, MOVA, hash 0. So what does this instruction mean? As I have told you, if you're going to store any number, any hexadecimal number from 0 to F in any register, you can simply write that number with a hash sign. The rest of the bits will be assumed 0. So this instruction is also going to occupy 2 bytes. 1 byte for the opcode, that is 74 is the opcode of this instruction. It will get stored in 0004, and 0005 will store the operand, that is 0 0. Similarly, at AR5, this is a 1 byte instruction. As you can see, there is no operand written along with the instruction, and it is going to occupy 1 byte or one memory location only. So what is the memory location? 0. The next memory location 0006 will store the opcode of the instruction add A, R5. And what is the purpose of add A, R5? The purpose of add A, R5, the purpose of this instruction is to add the content of register 5 and the content of accumulator and store the result in the accumulator. Similarly, in this way, all the instructions will be written, and as I've told you, if it is a 2 byte instruction, it will be occupying 2 bytes of the memory location. If it is a 1 byte instruction, it is going to occupy 1 byte of the memory location. Now let's take a program like multiply 25 by 10 using the technique of repeated addition. So 25 into 10 is equal to 250. So here 25 into 10 is equal to 250. Here 25 is a decimal number. They have written multiply 25 by 10 using the technique of repeated addition. Here 25, they are resembling the decimal number, not the hexadecimal number. So what they are saying, multiply 25 decimal number into 10 decimal so that you will get 250. So how you going to write this program using the repeated addition? Either you can write it 25 into 10, or you can multiply 25 or you can repeatedly add 25 10 times so that you will get the value 250. So if you add 25 10 times, you will get the same value as you multiply 25 into 10, that is 250 only. So how you going to write the program using this method, that is repeatedly adding 25 10 times? First, what I need to do, I need to clear the accumulator, that is I need to make the accumulator 0. So what I have done, move A, hash 0 means I am storing the value 0 0 into the accumulator. Now next instruction, move R2, hash 10. So I am setting the counter in R register R2. So I am making R2, I am storing R2 is equal to 10. Next instruction is add A, hash 25. Now I have cleared accumulator. The next step, what I will be doing, I will be storing the value 25 in the accumulator. So what I did, initially I made accumulator 0, means I erased the previous value. If there is any previous value written in the accumulator, I erased that value by making it 0 0, by storing the value 0 0 in the accumulator. Next I set the counter like I have written, since I have to add 25 10 times, so I have written 10 in the, I have stored 10 value in the register R2. Next I have stored 25 in the accumulator. Sorry, there is a little bit mistake. Next what I am going to do, add 825 means I'm repeating what I have done. I have set the accumulator 0. I have erased the initial value of accumulator. Next I have set the counter R2. Next step is add A, 25h, hash 25h means I am adding the content of accumulator with the immediate data and storing the result in the accumulator. Since the content of accumulator is 0 0 and the data is 25h, I am adding both these contents and I am storing the result in the accumulator. Means 125 is gone. 125 is gone. Now 125 is gone. Now what instruction that I will be using, DJNZ R2 again is this level. It is a loop, again is a loop that we are going to set. So DJNZ R2 means decrement the value of R2, and if the value of R2 is not 0, then jump to this loop. What does this instruction mean? DJNZ R2 again means decrement the value of R2, and if the value of R2 is not 0, then jump to this level again. So what will happen? Initially I made A is equal to 0 0. I set the counter, then I added 25 to the accumulator, that is 0, and I stored the result in the accumulator. So my 125 is gone. So one of the 25 value is gone. Next I have decremented the Next, I have decremented the value of R2. Since initially the value of R2 was 10, and after decrementing, what will be the value? R2 will be 9. So R2 is equal to 9. It is representing that there are 925s are remaining that need to be added. So since now decrement the value of R2 after being decremented, it is 9 and it is not equal to 0. So it will jump to the loop again. So again is starting from this to again what it is showing, what this level is showing, what this loop is showing. Again 25 will get added to A. Now after first time after adding 25 to the initial accumulator value 0, the result of the accumulator was 25. Now since we have again jumped to the loop, again we have jumped to this loop again. Now what will happen? Let me clear it. So initially the value of accumulator was 0. After one addition the value of accumulator is 25. Now since the R2 is not 0, it will jump to the loop again, and again the value 25 will get added to the value of accumulator, and the result will get stored in the accumulator. So next this time what will happen? 25 plus 25 means second 25 also gone, and the result will get stored in the accumulator. This result will get stored in the accumulator. Then the next step is decrement R2, dj nz R2 again, decrement R2 again, means again R2 will get decremented. Now initially the R2 value was 9, now it will get decremented to 8. It will get decremented to 8, and if since the value of R2 is not 0, this program will again jump to this loop again. So again this loop is there. Now R2 is equal to 8 means 8 more 25s are there which need to be added. In this way all the 1025 will get added, and the result 250 will get stored in the accumulator. Now once all the 25s are added and the R2 has been decremented and it will come to 0, there what will happen? It will no longer jump to this loop again. Now it will come to the next instruction, move R5A, means whatever the result stored in the accumulator, that is 250, it will now get stored in R5. So this is how you going to multiply 25 by repeated addition, multiply 25 by 10 using repeated addition through this microcontroller programming. So I'm ending this class here. In the next lecture also I'll be discussing few more programs. Thank you.